This video lesson deals with fluvial landforms and will mainly take the form of questions from past examination papers. Fluvial landforms are landforms created by the action of flowing water, especially rivers. Fluvial landforms can be classified into two groups, those created by erosion and fluvial landforms created by deposition. In the upper course, where the main fluvial process is erosion, waterfalls and rapids occur, while in the lower course, where deposition is the dominant fluvial process, we have the occurrence of floodplains, levees, braided streams, and deltas, all which are examples of depositional landforms. The lower course is also where meanders and oxbow lakes are found. However, meanders and oxbow lakes develop from a combination of erosion and deposition. A waterfall is a point in a river where water flows over a vertical drop in the river course. In other words, there is a sudden change or a sudden drop in the gradient of the land over which the river flows. In order for waterfalls to develop, we require a layer of hard rock which overlays a softer layer of rock. As the water travels over the edge of the waterfall and plunges down to the bottom, the force of the water creates a plunge pool at the base of the waterfall. However, the rushing water over the edge also undercuts the softer layers of rock, causing the softer rock to erode at a faster rate. The erosion and undercutting of the softer rock means that there is nothing to support the harder rock layer above it, and therefore the edge of the waterfall breaks off in stages, which then causes the edge of the waterfall to move or migrate upstream towards the source of the river. Question 2.2 from paper 1 of November 2021 reads as follows. Refer to the sketch which shows a waterfall with a plunge pool. Complete the statements in column A with the options in column B and write only X or Y next to the question numbers 2.2.1 to 2.2.7. 2.2.1 says that waterfalls form when X, they are alternating layers of hard and soft rock, or Y, they are only soft rock. So even according to the diagram, you will notice that there are layers of hard and soft rock, and that is the requirement for the formation of waterfalls. Therefore, the option would be X. 2.2.2, waterfalls are likely to be found in the upper course. Y is the option because in the upper course, erosion is dominant and waterfalls are examples of erosional fluvial landforms. 2.2.3, what refers to the softer rock that erodes faster? So in this case, in the diagram, it would be X, which represents rock type. A 2.2.4, the plunge pool is formed by deposition or erosion. The force of the water at the base of the waterfall erodes the base, and therefore the plunge pool is a result of erosion. So in this case, the option would be Y. 2.2.5, when the softer rock at C erodes, it will cause the rock at A to collapse into the plunge pool, or if the waterfalls to retreat downstream. The option is X. The rocks at A will collapse into the plunge pool. 2.2.6, the retreat, in other words, the moving backwards of the waterfall, will result in the formation of a gorge. Now, a gorge is a long, narrow valley that is created when the waterfall retreats upstream like that. And 2.2.7, an advantage of a waterfall is the generation of hydroelectricity, which is X. So in order to generate electricity, the power and the energy generated by the moving water is harnessed. Floodplains and levees develop in the lower course of the river and result from deposition. Floodplain is the flatter level area right next to the river, which is formed when the river deposits sediments on its bank after it has gone into flood. Levees occur right next to the river on the bank, and they are in essence raised embankments right next to the river which build up after repeated cycles of flooding. Question 2.4 is from November paper 1 2021. Refer to the diagram of a floodplain. 2.4.1 state the geomorphological process that gave rise to the formation of the floodplain. In this question, it was almost not necessary to even use the word geomorphological. The emphasis is on the process, and the answer in this case would be deposition, as floodplains are the result of the river depositing its sediment on its banks. 2.4.2 says to describe the gradient at X because the floodplain occurs in the lower course of the river, and the lower course of the river is found in a flat area. The gradient of the land next to the river on the floodplain can be described as flat or level. Suggests two reasons for the wide floodplain at X. In this case, it's important to remember what causes the floodplain, and that would be the fact that there is regular flooding, and during the flooding process, sediments are deposited. So in this case, the floodplain is quite wide at point X because of repeated flooding as well as additional or increased amounts of silt that was deposited on the riverbank. Question 2.4.4, in a paragraph of approximately 8 lines, explain the physical or natural impact of flooding on the floodplain. It's important for this question to remember that it doesn't specifically state negative or positive impacts. It simply speaks about impact, and you can then decide to do either positives or negatives or a combination of the two. I will address the answer to this question on the next slide. Some possible answers to question 2.4.4. The deposition of silt increases the width of the floodplain. The deposited sediment creates fertile soil, which allows for the growth of vegetation. It increases the quality of the soil. Levees form on the downside. Soils can become waterlogged, but continuous flooding can also have a negative impact on the growth of vegetation in an area. The diagram shows an example of what is called a braided stream. Braided streams occur in the lower course of the river, where the river flows over a flat or a level gradient, and therefore the dominant fluvial process would be deposition. In this instance, the deposition happens inside the river channel. As the deposits build up inside the river channel, they stick through the surface of the river. When looking at the river or the stream from above, it looks as if the individual streams have been braided or plaited. On occasion, braided streams can be considered as fluvial landforms, but I've also observed braided streams being referred to as a fluvial characteristic in certain question papers. River deltas occur right at the edge of the river, where the river empties out into the sea or into a lake. This point of the river is called the river mouth. As the river mouth is right at the edge of the river, it naturally flows over level or flat ground. As a result, the river slows down quite significantly, and it then deposits most of the material that it is carrying at this point. So as the river slows down at the river mouth, it will deposit the material at this river mouth. However, repeated deposition will cause the river to block itself at the mouth. This deposited material then builds up and starts extending into the sea. However, as the water then builds up behind the river deposits, it eventually makes its way across the deposited material in smaller streams to form what is called a delta. The following question comes from November 2020, paper 1. I've underlined the sentences we will require in order to answer the questions on the following slide. So question 1.5.1, deltas form at the river mouth or a lake or a point where the river enters the sea. Any one of those options would have been awarded 1 mark. Evidence from the extract that indicates that deltas are densely populated. The extract says that deltas are home to hundreds of millions of people. According to the extract, how are cities disturbing the natural formation of deltas? Groundwater is being pumped from aquifers or underground springs through permeable rock. Discuss the importance of protecting deltas. They are a source of water. They sustain plant and animal ecosystems. They ensure biodiversity. They provide fertile soil for agriculture and food production. Tourism and leisure activities at the deltas are able to generate a source of income. Deltas, according to the extract, are home to many people, places where settlements are built, and deltas can provide a source of food or protein in the form of fish. Question 1.5.5 was the one that was quite a challenge. It says a recent environmental impact assessment has highlighted concerns about the future sustainability of deltas. In a paragraph of approximately 8 lines, suggests strategies to protect areas like deltas from the negative impact of human activities. And so even though this question is loaded, it ultimately wants you to say what can be done in order to protect these deltas from the impact of human activities. I've underlined a few answers that are quite easy to remember based on the extract speaking about the number of people that live on the delta. So one strategy would be to limit the number of people living on these deltas, to reduce the infrastructure and infrastructural development on deltas. If tourism can create a positive impact to an area, then the emphasis around this delta should be on ecotourism, where there is equal importance is given to the benefits of tourism as well as conserving the natural environment. Buffering or fencing off the delta area, this is an aspect that is dealt with in the GIS section of the question paper. However, a delta can also be buffered in order to protect itself from the negative impacts of human activities. Feel free to read through all of the other solutions and take some time to remember them for future use or future reference.